Hey everybody, my name is Jesse. I'm one of the TAs here at U of H. I'm just going to do a quick safety talk for General Chemistry Lab 161. As far as we know now, we're probably not going to be doing any in-person labs for fall 2020. It could change, I don't know, it changes on a daily basis, but at the very least, I wanted to make a quick video just going over some of the lab safety and a little lab tour for you guys. So starting off, it's a safety video. We have a new piece of safety equipment we don't normally use. That's the face mask. You notice I don't have one on right now. I'm in here by myself. If anybody else was in here, better believe I'd have my mask on. Next thing is, anytime you're in your Gen Chem labs, you're going to first come and sit down. If it was in person, you wouldn't have your goggles on then. You'd be, listening to the TA talk about the lab. You'd take a quiz. But as soon as that stuff is done and you're ready to go to your hoods, you're going to need some safety goggles. These are some very basic ones. They sell at the bookstore. They're like a couple of bucks. If they're sold out, which happens pretty often, you can pick up a pair at City Mill, or any similar lab safety goggles will do. No biggie. Biggest thing is, this is your first line of defense. You want to protect your eyes. Stuff can splatter. You don't want to be hanging over the eye washing station for 20 minutes, flushing your eyes with cold water. If it comes to that, though, that's what you do. So a couple of important things is, if you're in Gen Chem, you will be using some chemicals. Considering it's the first year of chemistry lab, nothing too dangerous as you would use in organic chemistry or analytical or physical chemistry. But nonetheless, the biggest thing is, even if we're dealing with something that's not particularly dangerous, we want to instill in you these habits of safety. As you go through your undergrad education, if you're a chem major, this is going to get drilled into you to where when you go out into the real world and get a job or go to grad school, you're just going to do these things automatically. You're not even going to be sure why, but your training kicks in and you just do them. A big thing with the lab safety is, it's a lab. You don't want to be horsing around. You don't want to be running. In fact, when I'm carrying some reagent bottle, and I do such with maybe, 2 hands, I'm keeping an eye out, making sure I'm not, going across some corridor where somebody's going to, be coming around the corner really quickly. If you were to spill, some chemicals on yourself, the other part of this is dress code. You're not going to be wearing some running shorts, and a tank top and flip-flops. In lab, you got to have closed-toed shoes. A lot of my students would bring their shoes. It is Hawaii. You're going to be wearing your slippers. They'd bring their shoes. They'd put them on, at the beginning of lab. No big deal. It gets cold in Builder Edition, so I suggest, just wearing pants that day. Being that it's cold, you can always have a nice warm hoodie. Even if you don't have an in-person lab for Gen Chem 1, next semester for Gen Chem 2, you might be in person. So these are things to keep in mind. You are always free to go buy your own lab coat, and the benefit of that is a lot of people like to wear more summer clothing, shorter shorts, shorter t-shirts, kind of a thing. And if you put a lab coat over that, you're fine. You can kind of get away with a little bit more. You don't have to have a lab coat, but there's a benefit to it, especially if you're going to continue and do organic chemistry or some biology labs. It's a good thing to have. Okay, with that said, there's some SOPs that we want to keep in mind. You're dealing with chemicals, and so if there's a particular chemical we're working with and we indicate in the lab, hey, there's special waste procedure for this, we'll have waste bottles in the back of the laboratory. You'll be given very explicit instructions of what to do with your waste. Sometimes we're dealing with aqueous solutions, maybe acidic or basic, or maybe some sort of inorganic salt in there. these can typically go down the drain, but, and big but, they typically have to be neutralized first. I'm not just going to take a 6 molar potassium hydroxide or a 6 molar hydrochloric acid and dump it down the drain. It's not good for our pipes, and it's not good for the environment, and it's a sure way to maybe your TA is going to take away your points for the day for doing that. A quick story, I had some students last year in the 2019-2020 spring semester, and we were dealing with acids and bases, and at the end of the lab, these students wanted to get out of here. They wanted to, I don't know, go get some lunch or whatever. And without checking with me, they dumped the reagent down the drain, and I asked, what did you neutralize it with? The student replied, water. Maybe you don't know much about chemistry yet, but a strong acid or strong base does not get neutralized with water. It gets diluted, but as you'll learn, a base needs to be neutralized with an acid needs to be neutralized with a base. So now we have a good example of what not to do. So I guess what I should just do is logically give you a little lab tour and point out the things as we go along. If you were to get some sort of chemical in your eye, let's see here, we do have an eye washing station right here. It has these little saline eye squirters, and the idea is that if you get something in your eye, which shouldn't happen because you're going to have these to help you from getting stuff in your eye, you would take one of these off the wall and you would stand over the sink and really just flush your eyes out. The first thing to do if anything happens, if you spill a chemical on yourself or something dangerous happens or glass breaks, know your TA's name. As soon as it happens, call out to them. They'll come running, they'll come assist you, but know what you should be doing in the event of some sort of mini emergency beforehand, so you can get started on flushing your eyes out or taking off a jacket or lab coat that's soaked in some sort of a chemical. And again, we're not doing anything too crazy in Gen Chem lab, but still we want to take these precautions because your safety is most important. If there was a fire or a fire alarm, we have a procedure which you would be directed if you had it, of course, in-person lab. We have places where you need to evacuate the lab and go meet with the rest of the building so they can account for everybody and know that the building is clear in case of a fire or some other emergency. You'll be notified of where to meet when in fact you do have those in-person labs. Okay, let's just do the tour. Another part of safety, which we probably won't see go away anytime soon, is this social distancing thing. As I show you the lab, you'll see it's been reset up to allow for that. This is an important aspect, and it's really easy to be working and then, oh, I got to grab this reagent and you're super close to somebody. We can get kind of meticulous and smart about how we operate in a laboratory classroom setting. So I'm going to grab the camera there and take a little lab tour. Okay, let's see here. So, alrighty then, I got a little selfie stick like a jerk here. So, this is how the seating is now. You'll notice these signs, seats unavailable, look at that. So we have, basically one seat available per row. That should really ensure our social distancing here. And if we go over to our fume hoods, you'll see, well, there's only 2 stools. So it would normally be, we would have 2 people at this fume hood, 2 people at that fume hood, which isn't so crazy here on the ends. But you get over here to these bunched together ones, we got 4 fume hoods together. These hallways get very crowded. So we've accounted for that. When we do finally have in-person labs, I doubt we'll just have a full classroom off the bat. So hey, let's check out a fume hood. So your fume hood is going to consist, let's see if I can do this one-handed. So we have a gas knob, that one. We have a vacuum knob, okay. And sometimes these will have cold water, other types of things. You'll use Bunsen burners in Gen Chem 1, so that's what we use the gas for. You'll hook up a hose, you'll hook it up to your Bunsen burner, and we'll go through everything in each individual lab as we go. We're not going to go into too much detail just for this video. Okay, so we've done a new system of organization. It used to be you would have your lab drawers and you would have everything that goes with that station all in one drawer. Things were getting a little bit mixed up. What we do now is more of how you would see in an actual research lab. So I started recently working in Dr. Hevel's Organic Chemistry Research Lab, and this is exactly how they do this here. You would have one drawer where, okay, let's see here. Got this drawer. We only have beakers in this drawer, nothing but beakers. Go over to the next one. Erlenmeyer flasks. Next one. Graduated cylinders. Next one, test tubes, and so on and so forth. Yeah, we got stuff in there. So what you'll find is during the lab, you're going to need some sort of piece of equipment, and you're going to go looking through your drawers and you're going to realize you don't have it. It's going to take cooperation of all of you to go across the room and go talk to another student. Hey, do your drawers have the graduated cylinders? Does your drawer have a Bunsen burner, clamps, that kind of a thing? And explore the space, walk around the lab, familiarize yourself with what's in each drawer, and they're labeled, so that's even better. Here are the sinks. Yes. Okay, we got some sponges, we got some soaps. If you had some piece of glassware and you were uncertain what some residue was on it and you want your experiment to turn out right, clean labware is key. Take it upon yourself to clean and dry it if it's not to your satisfaction. And sometimes you do an experiment and the littlest bit of contamination can ruin your data, and you've wasted half a day. So let's see here. The other thing, these fume hoods. So this is the sash. It lifts up. What you'll find is when they're above a certain line, this is not how fume hoods work. They do not work properly like this. The point is to bring in a small amount of airflow to have a good suction, and then it flows out. So any fumes we generate, anything dangerous, it stays in the fume hood. You'll have a lot of students forgetting to turn the light on. There's a light, that helps you too. Okay. When the fume hood is too high, it's going to do that. It's very annoying. So when you're working, you're actually having it much lower, and you're working with your hands in the fume hood, and yeah, it's a pain in the butt, but you're going to have more labs ahead of you where you're probably going to use one of these. Get used to it. It's for your protection, so if something explodes, it doesn't, you don't get a face full of, I don't know, some sort of dangerous chemical. Yeah. So when that happens, sometimes you have to have this up high and you have to set up your apparatus. Well, if this thing beeps, press the alarm, but it's telling you, hey, come on, bud, let's lower that down. Okay. You also have electrical outlets. You're going to be setting up stir plates and some other stuff. Let's see here. Okay, let's keep going on our tour. Sorry if you get motion sickness easily, like I do. Okay, and again, we have more fume hoods. Just familiarize yourself with the lab space when you eventually come in. We have more fume hoods. So then over here, typically, we're going to have the reagents at, even though that is the front of the classroom, well, the door's right there, so I kind of consider this the front. This is where we are keeping, let me fix this. This is where we keep all of our reagents. And so at the beginning of each lab, if you're going to have some sort of chemical you need to retrieve, it's going to be out here in the front. Some pieces of equipment, I have a lot of students like, Jesse, where's the burette holders? Well, we keep them up here. Weigh boats, pipettes, your standard stuff. Looks like we have some lead, copper, and tin wires. This is probably for an electrochemistry lab. Yep, there's the salt U-tubes. There's the voltmeters. Okay, so over here, these are the waste stations. So if you're going to generate waste during your lab and your TA tells you, Make sure the waste goes in the waste container. This is where it's going. Broken glass. Broken glass goes in this nice big black box with a plastic bag. Certain things might also go in there besides broken glass, but anything sharp or broken, it goes in here. We don't want to put, oh, and another thing, your plastic pipettes. These, you're going to pipette some sort of chemical. These do not go in that garbage can. That's for non-chemical waste, you know, paper towels and stuff that don't have chemicals on it. It's a safety thing. You know, we anything that touches chemicals, we account for, and we take care of it in a very particular way. So, pipettes, certain chemical waste, broken glass goes in here. I don't know how your TA is going to delegate you dealing with broken glass. I tell my students, if you break something, and don't be embarrassed. It's a chem lab. Stuff is going to break. We expect it. That's not on you. You're here learning. It's a safe place to make those mistakes. I tell my students, if you break something, don't touch it. Just yell for me. And so I'll hear something break, and I'll hear, Jesse, and I come running. I like to clean up the broken glass for my students. I don't want them to get hurt. Maybe your TA is comfortable with you cleaning up the broken glass yourself. Regardless, you should tell them. Some students are embarrassed and they try to hide it, you know, and then maybe they try to clean it up real fast and they cut themselves. We don't want that. You know, we're fine. You break a beaker, you're paying tuition. You own that beaker. Don't just start taking stuff out of shelves and, you know, smashing it for fun though. These are the balances. In science, we don't weigh things, we mass them. There's a difference. So the biggest thing is when we start a lab, you'll have everybody, the whole class, all 24 students rushing to these, and it's a big crowded thing. If you're doing a lab, you're you know, when we're not social distancing, before all of this craziness, I would tell, you know, students like, hey, one lab partner, go get the reagents, weigh them out, mass them out. The other one, set up the fume hood, set up the, you know, the reaction. And that's perfectly fine. You know, it doesn't take two people to do one thing if you trust your lab partner. I don't know if you'll be having lab partners when you return to in-person lab. But yeah, you know, utilize that teamwork. Again, you know, here we have, you know, we're on the other side of the lab room. So now we have different kinds of equipment over here, clamps and ring stands. So, you know, somebody at this fume hood's gonna need a graduated cylinder. They're going to the other end of the classroom. Somebody over there is gonna need, you know, a clamp. They're gonna come to this end of the classroom. And when you're done, you're gonna put those things back. Not all labs are the same. Sometimes we'll have different stuff set up over here, you know, just depending on what kind of reagents we're using, what equipment. A common thing is DI water. When we do things in chemistry, we don't just use water from the tap. We use DI water because it has all of the ions and, you know, just kind of stray stuff in there taken out. Because the littlest bit of some ionic change can affect your pH, you know. Okay, we usually also have, if we need dry ice, it'll be over here. If you are going to use a heating mantle, which also doubles as a stir, we use magnetic stir bars. We keep them under here. Yeah, there's our digital stir. I'll give you a little close-up. And, you know, it has a heat adjustment. It has, you know, stir speed and stuff like that. Don't trust the temperature on there. You would typically put an actual thermometer inside of your reaction vessel, and you could monitor the temperature that way. It's a much more accurate way of doing things. Oh, yeah, and so I need to give a little bit more info on the safety. So we have this thing over here. This is the chemical shower. Every lab should have one. This would be your worst case scenario. We want to avoid using this at all costs unless absolutely necessary. Because what this does is you pull this lever, I'm not going to do it, and water just starts coming out like you wouldn't believe. And what I've been told, the fire department has to actually come and shut this one off. The last, the community college I went to, their showers had a reservoir, so eventually it would stop. That's not the case with this. This is if you're bending over to tie your shoe and somebody, drops a liter of, 6 molar hydrochloric or sulfuric acid on you, and if you're doused in chemicals from head to toe, that's why we use this. And you're actually, you want to avoid this, because if it happens, you got to come in here, you got to pull the shower. You're actually supposed to take your clothes off that are affected by it, and your wallet's going to get wet, everything. I can imagine that being a little embarrassing. We do have an eye washing station here. This you can use without it coming to no end. I pointed out the saline ones out in the front. That's kind of an older, portable way of doing things. I would prefer you using this eye washing station, and you're just going to take it, flip the thing off, and you're going to literally, look down and point it up at your eyes. And I mean, when you get something in your eye, you're supposed to flush it with cold water for, anywhere from 10 to 30 minutes, depending on the reagent. Stuff in this kind of lab, I would say more like 10 minutes. Organic chemistry, we get into some more hefty stuff that you would be rinsing for a full 30 minutes or more. Okay, let's see. Sometimes there is additional equipment we need for labs down here. Actually, I see now, this is probably where the pipettes are going. So when you pipette something and there's chemicals left over inside that pipette, we don't put it in the garbage because it's chemical waste. We would put it down there. Okay, we do have, you might notice these fume hoods. They have lab stools. You're free to stand the entire time. I've had students that had issues with low blood sugar or something. People have fainted, and if you're feeling faint, tell us. Don't be a hero. We'll probably have you go sit down in one of the classroom seats, maybe eat a power bar, drink some water. But if you're prone to this, you can pull up a stool and work at your fume hood like that. Paper towels, that's something we use. Yeah, okay. I think as far as the basic stuff that covers us, one last thing, sometimes we'll do some kind of extra neato experiments, and we'll have some, spectrometers over here, Yeah. Okay, so I think that about wraps everything up. I hope this was at least a little bit informative for you if you maybe didn't have any exposure in high school chemistry, or you wondered what a general chemistry lab looked like. When I took Gen Chem, we just had table benches, so I think it's to your benefit that you get to start using the fume hoods a little bit early. Of course, once you start doing labs in person again, so hopefully that'll be happening pretty sooner than later. All right, everybody, thanks. Stay safe.